tricky political issue. If you add up all of the carbon that's been produced from 1900 till 2002, that's what we have here, you'll see that one country is responsible for 30%, nearly a third of the whole problem, and that is the U.S. So when you go to these international negotiations, like in Copenhagen last December, you have all these countries saying to the U.S., well, you have already had your free lunch. You have already used everything you wanted to use. It's our turn to keep up. So why should we limit our use of these fuels if you caused a third of the problem? But then the U.S. says to these other countries, with some justice, it says, well, we did produce a lot of the problem in the past, but just last year, China took over from the U.S. as the largest producer per year on an annual basis. So the U.S. says, well, why should we reduce our emissions when China's producing more than we are, so it won't make a big difference anymore? And so this is the impasse that we're stuck in at the international level, whereas the truth is that entire continents, like Africa and Brazil, did not produce this and are not producing these gases in the future compared to the rest of the world, but they are the ones who are feeling the largest effects. Well, so the next question is, okay, we produce these gases, and I understand that the atmospheric levels are going up. How do you know that that is what is actually causing climate change? If you go to the next slide, the way we do it is, what we would really like actually is another planet that looks exactly like our own, maybe on the other side of the sun. And the only difference is that planet doesn't have any people on it, and our planet does. So if that planet were heating up, and ours was, we would know that it wasn't us. But if that planet was not warming, and ours was, then we know that had to be us. But unfortunately, it's a little bit late to get an extra planet. So what we do instead is we create that planet using the most sophisticated and complicated and large supercomputers in the world that we can lay our hands on. And into those models, we put everything we know about the planet. Ocean circulation, clouds, forests and trees, plants, people, natural cycles, the sun, everything we know goes into those models. And using those models, we can create that Earth with no people. So if you go to the next slide, that's exactly what we have here. What you see here is our global average temperature for the last century. That's the black line. That's actually observed, measured with thermometers. And the blue lines are all of our different climate models run with changes in energy from the sun and natural cycles and volcanic eruptions. Those are those straight lines there. Every time we have a big eruption, it gets cooler for a couple of years afterwards. And what you see is that for the first part of the 1900s, there's a pretty good correspondence between the two. But over the last part, since about 1960, if our climate were being controlled by natural causes, it would be getting cooler. But instead, we see it's actually warming faster and faster. So everything we know about natural influences on climate cannot explain the warming we've seen over the last 50 years. So then what we do is we run the very same models, and the only difference is we put in humans, and that's the next slide. Once we put in our human emissions of these heat-trapping gases, we get a nearly perfect correspondence between what really happened and what the models say should have happened if humans are driving climate change. And so we cannot find any other explanation, and that is why humans are the only reason we can find for the observed increase, especially over the last 50 years. Now, all this may be fine and good, but what about? So if you go to the next slide, we hear a lot of questions about climate change, and so I'm just going to go through a couple of the most frequent ones that you might have heard. And in our book, we talk about a lot more of them. Our book is actually available online for free. You don't have to buy it unless you want to spare your eyes the stress of reading on a computer screen. And in the book, we go through a lot of the frequently asked questions that I've heard from people all around the country. One of the major questions we get, next slide, is, it is snowing. It snowed in Houston. It snowed in Washington, D.C. It's record cold or record snowstorms. How can you talk about climate change when it's freezing outside? Well, the fact of the matter is that is weather. Weather is how conditions change from year to year, or even from day to day. And weather is inherently unpredictable. You can get a very warm year and you can get a very cold year. But that tells us nothing about climate change itself. If you go to the next slide, climate is the long-term average of weather over decades. It is not that single cold year or that single snowstorm. It is what the average weather conditions have been like over 30 years or more. So there is no incompatibility, no inconsistency between the fact that we could have a record cold, because that's just weather, and we could still have global warming at the same time. Another common question is, next slide, a lot of these thermometers are located in cities where people live, and these cities have been growing over time. So isn't what we are measuring just the fact that cities are growing? Well, there's a simple way to look at this. You can look at where people live. There's a picture of the Earth at night on the top. And then you can look at where it's warmed the most. There's a picture of that on the bottom. And what we see is, in fact, it's warmed the most and the fastest where people don't live, not where they do. So we are not measuring the expansion of cities with the urban heat island effect. We are measuring a real change in temperature that's been happening over time. If you go to the next slide, another common question we get these days especially is, what about those stolen emails? Didn't they prove that global warming was just a big hoax? They talk about tricks to manipulate the data. Well, here's the truth. The fact is that everything like that trick discussed in the data, in the stolen emails, had actually been published in the scientific literature for years. The tree ring trick had been published since 1998. Stephen Colbert said something very apt. He said that if you want to hide something, the best thing to do is to publish it in the scientific literature. Because if you do, no one is ever going to read it. And that's exactly what we've seen. They could have spared themselves all the trouble of that hacking if they just, gone through some of the back issues of Nature and Science magazine. So nothing was hidden. And not only that, but the global temperature records that they keep at that UK site are mirrored by global temperature records at NASA, at NOAA, and in Japan. Not only that, but as we saw before, there's 26,000 physical and biological systems that tell us the Earth is also warming. So if it was a big hoax, they would have had to coordinate with NASA, with Japan's Meteorological Society, with NOAA, and with all of these birds and plants and animals and butterflies and insects all over the world, which is just ridiculous. I mean, the magnitude of the conspiracy required boggles the mind. The bottom line is simply that a few personal emails have no impact whatsoever on our overall understanding that human activity is driving dangerous levels of global warming, period. A similar question we often get asked on the next slide is, aren't scientists always disagreeing? And so what I did here is I pulled out two statements, and these statements say very similar things. Both statements say that climate is changing, that it's being brought about by increases in heat-trapping gases like carbon dioxide, and those gases are increasing because of human activities like burning fossil fuels. Now, if you go to the next slide, that first statement is from the conclusions of the IPCC report in 2007. The second statement was from a British engineer who wrote that in 1938. So far from the science changing from year to year, it's almost embarrassing how little the science of climate change has changed in the past 100 years. The very first climate model was designed and run, calculated by hand in 1890. And the answers that that climate model got for how much the Arctic would warm are astonishingly close to our best climate models that we run on supercomputers today. So no, if you go to the next slide, humans are the only explanation, and we have known that for over 100 years. Whatever continent you look at, you see the observed warming, that's the black line, and you see the warming that would be expected because of natural causes, that's the blue line, and then you see the warming that would be expected from natural and human causes, and that is the pink line. And on every continent in the world, we cannot explain the warming if we leave humans out of the equation. So, next question. Why should I care? Well, the Bible offers us actually some really good reasons why we should care. In Corinthians, Paul says everything is permissible, but not everything is beneficial. Yes, you can pollute as much as you want, but you're not necessarily going to get some good results from that. In Galatians it says, whatever a man reaps, this also he will sow. Whatever he sows, this he will reap. And this is exactly what we're seeing. We have been treating the atmosphere like a free garbage dump, to be blunt, for the last several hundred years. And we are starting to reap the consequences of what we have done. If you look at the next slide, this shows the global temperature change that we've seen over the last 1,000 years, and we're already concerned about this. We've already seen some pretty substantial changes here. But the changes we have seen over the past century pale in comparison to the changes that we expect over this century. Next slide. The changes that we expect over the next 80 or 90 years are the same magnitude as the difference between the last ice age and now. But that temperature change, instead of happening over 1,000 years, which gives our natural environment lots of time to adapt, those changes are expected to happen over just 100 years or less. Now, if we blow up that last part so it doesn't look quite so scary, you go to the next slide, you see that the amount of climate change does depend on the choices that we make. If we could flip a magic switch today, we would still see some amount of change, about 1 degree Fahrenheit. That's the green area here. If we could reduce our emissions about 80% by 2050, we would see a change between about 2 to 6 degrees Fahrenheit around the world. If we continue on our current pathway, depending on fossil fuels, we are going to see changes between about 6 and 13 degrees, but honestly, we are already on track to exceed that over the past 10 years. So we are currently on track to go even higher than what it shows here. What does this mean for our world? Well, if you go to the next slide, we say, well, what would happen if you could pretend as if you could pick up Massachusetts and move it to where it would feel like in the future? What we see is that a Massachusetts summer would feel like Maryland does today under lower emissions, and it would feel like Virginia and then eventually like South Carolina does today under higher. This is not something people in Boston are very happy to hear. If you go to the next slide, it shows the same thing for Chicago. Chicago summers under lower emissions could feel like Knoxville, Tennessee. Under higher emissions, they could feel like Birmingham, Alabama, and eventually like Baton Rouge in Louisiana. But the winters are not following the same path. Chicago is still expected to get a lot of snow in the winter, and so it would feel like Cleveland and eventually like Pittsburgh does today. So it's kind of a lose-lose situation, really. If you look at the next slide, this shows how many weeks per year we currently experience over 100 degrees Fahrenheit. Only people lucky enough to live in Texas, like I do, experience more than a week or two over 100 degrees. Our average here in Lubbock is actually about a week and a half. But as we go into the future, the next slide, you see that under lower emissions, nearly all of the Great Plains and the Southeast would experience at least a week, maybe even 3 or 5 weeks, over 100 degrees every summer. Under higher emissions, the next figure, we expect to see the entire country experiencing weeks and even entire months worth of days over 100 degrees Fahrenheit every year. This has enormous implications for our electricity demand, for our water supply, for the types of crops that we grow. This is going to affect our lives in all kinds of ways. If you go to the next slide, it's already affecting the world in really the most precious way, and that is the fact that climate change is causing deaths already. In 2000, 50,000 deaths per year. In 2009, 300,000 deaths per year. 300 million people, most of them living in areas subject to droughts and famine and coastal areas that will be flooded, are already at risk from climate change today. In 2003, next slide, in Europe, they had a major heat wave event that was responsible for over 70,000 deaths. 70,000. You can't pin one event like this heat wave on climate change, but what we can do is we can calculate how we have been changing the odds. And what we see is that we are loading the dice against ourselves. We are increasing the risk of one of these events. Other areas of the world are experiencing water shortages. 1 billion people around the world, a sixth of the world's population, depends on glacier melt for their water supply. Cities like Lima, Peru, that depends on this glacier shown here for its water, are rapidly running out to the point where their free source of water might be gone within literally a decade. It's not just other countries. Here in the U.S., the state of California gets half of its water from mountain snowpacks. And 70 to 90% of that could be gone before the end of the century. It all falls as rain in the winter and it washes out to the ocean instead of being stored in this natural reservoir of snowpack and then melting in the spring when you need it for agriculture and for your lawns. For our coast, if you go to the next slide, what we're